Mr. Rat here, and welcome to this film on circles, on areas of circles and circumferences of circles. These questions are all pretty feisty, grades 7, 8 and 9. Hit the link in the description, download the questions and have a go at them yourself. If you'd like to, of course, you can watch the film whilst you're doing the questions and you can work alongside me. Up to you. This is a really good topic for those of you going for the top grade because very often these questions appear towards the end of the paper, and these are the questions which differentiate between those of you who will end up with a 7, an 8 or a 9. So spend some time on these questions and good luck with them. Right, let's get on with the maths. Question 1. Right, A, B and C are points on the circle, and then I'm told the radius of the circle, which is marked on the diagram, and I'm told that angle ABC, which is an angle on the circumference as well. And I'm asked to work out the perimeter of the shaded sector, giving my answer to 3 significant figures. Okay, let's have a look. So if that's the angle at the edge of 132, then that's the angle at the centre would be double 132, 264. So I'm really just being asked for the perimeter of the shaded sector. So I'm being asked for, let's start from the centre, I'm being asked for that length. Well, I know that's 8.5, plus this length all the way around the circumference. Well, it's not all the way around the circumference, it's a fraction of the circumference, and then this length here, which again is 8.5. So I'm being asked for the length of that red line, 2 8.5s, and a fraction of the circumference of the circle. Well, the circumference of the whole circle is pi d, and the diameter of the circle is double 8.5, 17. So the circumference of the whole circle is pi times 17. And I've only got a certain fraction of it here. I've got 264 degrees out of 360. So the length of the red curved line there is 264 360ths of 17 pi. So that's that bit. So the perimeter of the shaded sector will be 264 360ths of the circumference plus 8.5 plus 8.5, the two straight red lines. So if you put that into your calculator, you get the answer 56.165 and so on. And so to 3 significant figures, 56.2. Question 2. OAB, that's the diagram there, is a sector S of a circle with centre O and that radius, which is marked on the diagram. And I'm told the angle is 45, the angle at the centre, but that's marked on the diagram. Okay, so that's that. Now I've got another circle. A circle C has a radius of r minus 2 meters. Okay, thanks for telling me. Right, the area of the sector S, which is this one here, is twice the area of the circle C. Okay, find the value of R. Right, let's have a go. So the first thing I need to do really is to find an expression for the area of the sector S. That's an area, that's the area of this diagram here. Well, the area of that whole circle would be pi times the radius squared. And I've only got a certain fraction of that, haven't I? I've got an eighth of it, in fact, 45 degrees out of 360. So the area of sector S is pi times r plus 7 squared divided by 8. So now let's have a look at this one. The area of sector S is twice the area of circle C. So we better find out the area of circle C. Well, circle C, the area of that, well, it's got a radius of r minus 2. So the area of circle C is pi times r minus 2 squared. So now I think I'm ready to set up an equation because the area of sector S, which I've got at the top, is equal to twice the area of circle C. So my equation is going to be the area of sector S over 8 is twice the area of circle C. So there's an equation, and I need to solve that equation now to find R. So now it's simply a question of not messing up your algebra. Right, if it were me, I'd start by multiplying both sides by 8 to give me pi r plus 7 squared equals 16 pi times r minus 2 squared. Right, I'm going to divide both sides by pi, and I'm also going to write r plus 7 squared out as r plus 7 times r plus 7. So if the pi's gone from the left, the pi will go from the right, and also I'm going to write r minus 2 squared as r minus 2 times r minus 2. Stop me getting that wrong. Right, I'm going to multiply out these brackets on the left, r squared, 7r, and another 7r, plus 49 7/7s at the end. And now I'm going to leave this 16 here and multiply out these two brackets, r minus 2 squared. So r squared minus 2r and another minus 2r. Minus 2 times minus 2 is plus 4. Don't mess that up. Okay, let's multiply out that bracket on the right-hand side. Remember, you just need to do this carefully. Okay, there's no point in working quickly and making a mistake. I've multiplied out that bracket there. Now this is going to be a quadratic equation. I'm going to set it equal to 0. So I'm going to subtract r squared from both sides, subtract 14r from both sides, and subtract 49 from both sides. Leave me with 0 there. I'll only have 15r squareds now. I've got minus 64r, and I'm taking away another 14, so that's minus 78r. I've got plus 64, take away 49, leaves me with plus 15. Right, so this is a quadratic equation now. I'm going to write it out with the 0 on the right-hand side because I find that easier, and I'm taking my time, as you should. Right, factorise the left-hand side. Well, I can take out 3 as a common factor straight away. Okay, leaves me with... There we are, I've divided each of those terms by 3. Now, can I factorise it further? I suspect I can, because I've got 5r squared and 5. It's looking to me as if we could factorise this into 2 brackets, but of course you could use a formula if you insisted, but I'm going to factorise that. It's going to be 5r and r. Right, now I'm looking for numbers which multiply to 5, and I need to have minus 26, so I'm going to have a minus and a minus. If I put 5 and 1 like that, I get minus 25r from the outside, minus another r gives me minus 26r, so I factorised it. So what are my two solutions for r? Well, r could be a fifth or 5. Okay, a bit bizarre, there are 2 answers for r because I'm only expecting one answer. It says find the value of r. Now, the secret here is to realise that the circle C, its radius was r minus 2. So if r was a fifth, as it can be algebraically, then this circle C would have a negative radius. Well, obviously that makes no sense. So we're going to discount that answer. And so my answer is that r is 5. And that is the solution for question 2. Question 3. Right, the diagram shows 4 identical circles. Yes, it does. Drawn inside a square. Yes. Each circle touches the other 2 circles and the 2 sides of the square, just like it's drawn in the diagram. The region inside the square that is outside the circles, the shaded region, has a total area of 40. Work out the perimeter of the square. Give your answer correct through significant figures. Right. So I'm given no measurements at all, except I do know that that shaded area equals 40. Right, well, I've got to start somewhere. So I'm going to start by assuming that the square has side lengths of x. And now I'm going to develop an expression for the shaded region and set that expression equal to 40. Because the information I'm given is about the shaded region equaling 40. So let's get an expression for the shaded region and set it equal to 40. Right, an expression for the shaded region. Well, let's have a think. If I assume that the square has side lengths of x, then the radius of one of those circles is going to be 1/4 of x. Okay, right. So the shaded region then, the shaded region is going to be the area of the square, which is x times x, minus 4 circles. Well, the area of one of the circles is pi r squared, so that's pi times x over 4 squared. So I just want to take away 4 of those, so 4 times pi times x over 4 squared. So there's an expression for the shaded region. Let's just recap that. It's the area of the square, subtract 4 circles. Okay, right. That's the shaded region, and I know I can set that equal to 40. So my equation then for x is going to be x squared minus 4 pi x over 4 squared equals 40. All right. Well, I better get solving, I guess. So I'm going to x squared minus 4 pi. Right, if I square x over 4, I get x squared over 16 equals 40. Right, I can simplify here and here. Okay, so that's going to give me x squared minus pi x squared over 4 equals 40. Let's multiply everything by 4. 4x squared minus pi x squared equals 160. Now I've got to solve this for x, so the secret is going to be I'm going to factorize it and divide. I'm going to FAD here, factorize and divide, because you see how you've got x squared in both of these expressions. So I'm going to factorize, take out the x squared, 4 minus pi equals 160. So therefore, x squared equals 160 divided by 4 minus pi. Okay, so now I can find x. So 160 over 4 minus pi, I'll put that into my calculator and square root it. On my calculator, when I put 160 over 4 minus pi in, I get about 186. So I'm going to square root that to give me x equals 13.65. Right, so I found x, I found the length of the square, the length of the side of the square. Square is 13.65 by 13.65. Now what's the question ask me? It asks me for the perimeter of the square. So the perimeter of the square is going to be 4 times 13.65. So 4 times 13.65 on my calculator is 54.61. And so, correct to 3 significant figures, my answer is going to be that the perimeter is 54.6. That is question 3 done. Question 4. Right. The diagram shows the cross-section of a circular water pipe. Okay. You've got the sector of the circle with a centre O. Well, that's marked quite easily on the diagram for me. The shaded region in the diagram represents the water flowing in the pipe. Okay, so the pipe's barely full, is it? This is the water here. Okay. The water flows at a rate of 14 centimetres per second in the pipe. Work out the volume of water that has flowed through the pipe in 3 minutes. Give your answer in cubic centimetres correct to 3 significant figures. Okay. Now, the first thing I need to work out is the area of the cross-section of the water. I need to work out this area here. Now, once I've worked out that area, I'll be able to multiply it by 14 to work out how many cubic centimetres run through the pipe in a second. But the first project is to work out that red area there. Now, the red area, I'll do it in red, is going to be the area of this whole sector, here, subtract the area of that triangle. So, the area of the sector, well, it's the area of the whole circle is pi times r squared, so pi times 4.8 squared. And I've got a certain fraction of that, haven't I? It's 72 degrees, so it's a fifth of the whole circle. So the area of the sector is pi times 4.8 squared over 5. And from that, if I want to just get that red area, I need to subtract the area of this blue triangle. I don't know if my shading's making it any easier for you. So I need to find out the area of that blue triangle there. How am I going to do that? Well, I'm going to use the formula on the front of the paper for the area of a triangle, which is a half AB sine C, because I've got the 72 and I've got the 4.8 and the 4.8. So the area of the triangle is a half times 4.8 times 4.8 times sine 72. So I can put that in my calculator and work out that the area of the triangle is 10.956, and so on. So the area of the water is the area of the sector of the circle here minus 10.956. So the cross-sectional area of the water there is 3.52 square centimeters. Great. So if the water flows at 14 centimeters per second, then in 1 second, 14 times 3.52, which is 49.28 cubic centimeters of water flows out of this pipe in 1 second. Great. So what's the volume of water that will flow through in 3 minutes? Well, 3 minutes, if it's 49.28 in a second, times by 60 to get how many cubic centimeters it is in a minute, and then times by 3 for how many cubic centimeters flow flew in 3 minutes. So if I put that into my calculator, I get the answer 8,871.125 and so on, and I'm asked to give the answer correct to 3 significant figures. So the answer is 8,870 cubic centimeters. That's the volume of water that flows through the pipe in 3 minutes. Okay, right. Question 5. I've got a diagram here with a pentagon drawn into the middle of it, and all the information is on the diagram except that the pentagon has side lengths of 8. So I'm going to write that here so I don't forget it. The diagram is shaded such that the shaded area is equal to the unshaded area, and I need to work out the radius of the smallest circle. Giving my answer correct to 3 significant figures. Right, well, this is a later question on the exam paper. It's quite involved, so slow and steady wins the race. Right, let's first of all find the areas I can find. Now, I'm able to find the area of the pentagon, because the pentagon is made up of 5 of these isosceles triangles. Okay, so I can find the area of those triangles. In fact, let's draw one of the triangles here. Here it is. Okay, it has a top angle of 72, so isosceles. It has a base of 8. So how can I work out that area? Well, I really want to be able to work out this side length here, which incidentally is also the radius of the circle. So how am I going to do that? Well, I can find these missing angles here. Top angle of 72, and it's an isosceles triangle. So this angle here is 54, as is this angle here. Right, so now I can find the radius by using the sine rule. R over sine 54 is equal to 8 over sine 72. Multiply both sides by sine 54. R is equal to sine 54 multiplied by 8 over sine 72. A bit of calculator work tells me the radius of the circle is 6.805. So that's fine. So now I can work out the area of that triangle, because I can use a half AB sine C. So that'll be a half times 6.805 times 6.805 times sine 72. Okay, so the area of that triangle is 22.022, which means the area of the pentagon is going to be 5 times 22.022. So the area of the pentagon is 110.11055. I'm keeping a note of all the digits so that my accuracy isn't compromised. Right, so what have I worked out so far? Well, I've worked out the radius of the circle is 6.805, and I've worked out the area of the pentagon there. Good. Now, it would be useful to be able to work out this area here, because then I could work out the total of all of those 5 areas, which are the same. Let's have a look. This area here. Well, that area is just the area of the sector of the circle, subtract the area of the triangle. So that area, the red area here, is going to be the area of a fifth of the circle, so pi times the radius squared over 5, that's a fifth of the circle. Subtract the area of that triangle. Well, I already know the area of the triangle is 22.022. So the area of one of those little slices is 7.074. So the area of 5 of those slices is obviously 5 times that. Right, so I've worked out quite a lot already. I've worked out the radius. I've worked out the size of one of those little red slices. And I have worked out the area of the pentagon. So now I'm ready to go back to this information I was given in the question. The shaded area equals the unshaded area. Well, if I call the radius of my mystery radius here, if I call that R, then the shaded area is the area of that little circle plus the 5 little slithers, so it's plus 5 times 7.074, and I know that equals the unshaded area. Well, the unshaded area is the area of the pentagon, which I've already found, subtract the area of that small circle. So there is an equation I can solve to find the radius of the small circle. Add pi r squared to both sides, so I get 2 pi r squared equals, subtract 5 times 7.074 from both sides, and I get 2 pi r squared is 74.74055. Divide both sides by 2, gives me that pi r squared, the area of that circle in the middle, is 37.37. Keep all those digits on your calculator. Divide by pi, gives me r squared is 37.37 divided by pi. Put that on your calculator and square root it, and you will have r is equal to 3.4489, and so on. And in the question here, we are asked to give r correct to 3 significant figures. So the answer is 3.45. And there is my solution to what is quite a drawn out question on the GCSE question. It's question 22 on a paper, and it's worth 6 marks. So it's question 22, so we know it's tricky, and it's worth 6 marks, so it's a valuable question. So work your way through that one again if you need to, so that you understand every step. Question 6. Right, I've got a sector of a circle. Okay, and most of the information here is on the diagram for me. That's the radius of the circle. And I've got the point A, which is on OB. Yes, it is. And the point D is on OC, such that OA equals OD equals 6. So I'm just going to mark that length there as 6, so I remember that. Angle BOC is 50, that's marked on the diagram. Given that the perimeter of the sector, OBC, equals twice the perimeter of the triangle, find the value of x. So I'm going to set up an equation here, and I'm going to need an expression, first of all, for the perimeter of the sector OBC. So let's do that first. The perimeter of the sector OBC. Right, well, that sector has got two straight components. So the perimeter of the sector, so I'm going to write sector here, OBC. So the perimeter of the sector is going to be the 6 plus the x plus 6 plus x, two straight lines, plus that fraction of the circumference. So plus 50 over 360 times by pi d. Now be careful because the diameter is 12 plus 2x. So here is an expression for the perimeter of the sector of the circle. Pi and times 12 plus 2x. Now I might as well just continue to simplify this, I think, for the time being. I'm going to multiply out this bracket, so I'm going to have 5/36 pi times 12 plus 5/36 pi times 2x. Let's continue with this. 12 plus 2x plus the 12 cancel gives me 5/3 of pi, and the 2 and the 36 will cancel, gives me 5/18 of pi x. So there is an expression simplified for the perimeter of the sector OBC. And next I'm going to find the perimeter of the triangle OAD. Right, the perimeter of the triangle OAD. Let's have a look at that triangle OAD. I'm going to draw a diagram here. Okay, it is a triangle OAD, 6 and 6, top angle of 50. Well, I can straight away find those bottom angles as 65. Now, if I'm going to find the perimeter, then I'm going to need to know this length x here. I'm going to use the sine rule to find that length because I've got a 6 here and the opposite angle, and I know the 50 here, so I can use the sine rule. So x over sine 50 will equal 6 over sine 65. Multiply both sides by sine 50, and x will be 6 over sine 65 multiplied by sine 50. So I can put that in my calculator easily enough and discover that x is 5.714. So the perimeter of this triangle is going to be 6 plus 6 plus 5.0714. So the perimeter is 17.0714. So now I've found the perimeter of the triangle OAD. So I'm in a position now to use this statement here. The perimeter of the sector OBC, well, I know that that is this, equals twice the perimeter of the triangle. So we'll equal twice that. So I'm going to have 12 plus 2x plus 5 over 3 pi plus 5/18 pi x, and that has to equal double 17.0714, 34.14203. I'm keeping all the digits on my calculator because that will help me with my accuracy. So I can subtract this from both sides and the 12 from both sides to give me 2x plus 5/18 pi x equals 16.906. Now it'd be useful to factorize the left-hand side really to pull out these x's, leaves me with, because how many x's have I got altogether? Well, I've got 2 plus 5/18 of pi x's altogether. So now I simply have to divide both sides by 2 plus 5/18 of pi. So that gives me an x equal to 5.885, or as the question asks, what does it ask for? 3 significant figures. My answer is going to be 5.89. And there is my solution for what is quite a feisty last question on the film. Well done for making it through those questions. I wonder how you found those tougher ones. With any luck, my solutions were helpful and you are clear on how you might tackle these questions when you sit the exam yourself. If you found the film useful, please hit like. Please tell me so in the comments. If you have any suggestions for me or anything you'd like to see more of in the channel, of course leave a comment too and I will respond. Lastly, if you are preparing for your IGCSE exams, then do subscribe to the channel. You will find much more content on the channel which will help you out as you look forward to your exams. Right, thanks for watching. See you in the next film.